Okay, question number 11, maximum mark 18 points. The points A, B, C, and D, the question gave us the coordinate of A, B, C, but not D. Form a parallelogram A, B, C, and D where D is diagonally opposite B. Find the coordinate of D point. So we can draw a diagram, a parallelogram A, B, C, D like this. So let's say this point is A, B, C, D, and then it says D is opposite of B, right? We can just write down the coordinate one more time. This is 1, negative 4, 0. Negative 4, 0. B point is what? Minus 3, negative 3, minus 6, minus 3, minus 6, comma 2. And then C point is minus 1, minus 2, 4. Minus 1, minus 2, comma 4. Okay, and then find the coordinate of D. Coordinate of D point, so coordinate D point can be defined by OD vector. OD vector is equal to, we can start with OA vector plus A to the D vector. This is OD vector, exactly the same. Because AD vector, A to the D vector, exactly same as BC vector. Because this is parallelogram, we can write it down this to like a OA vector, which is OA vector is what? 1, negative 4, 0. 1, negative 4, 0 plus AD vector is BC vector, BC vector. So minus 3 to minus 1 is plus 2. 2, minus 6 to minus 2 is 4. From 2 to 4 is 2, like this. So if you calculate this, we got 3, 0, 2. This is OD vector. It's the coordinate of D. So D point is 3, 0, 2. This is the answer. Okay, so D point we got 3, 0, 2. Okay, the diagonal of the parallelogram AC and BD intersect point E. Find the coordinate of E. So E point is intersection point of AC and BD. Right over here is E, which is exactly midpoint of AC. So midpoint of AC. So we can decide point of E is midpoint of AC. We can just directly calculate A and C midpoint. So X coordinate 1 minus 1 divided by 2, comma, y coordinate negative 4, negative 2 divided by 2, comma, z coordinate 0 plus 4 divided by 2. This is the E point, and just simply calculating it, we got 0, comma, negative 6 divided by 2 is negative 3, comma 2. This is point of E. So E point, we got it. Point E coordinate is 0, negative 3, 2. Okay, and then given that AB cross product AD is M times negative 1, 1, negative 1, where M is a positive integer, find the value of M. So AB cross product AD, that's all we have to calculate. So let's calculate it. So A to the B vector cross product to A to the D vector. Is that what? Question mark AB, AD. So equal A to the B vector. We got 1 to the negative 3 is negative 4. Minus 4 to minus 6 is negative 2. And then 0 to 2 is 2. Okay. Cross product of AD. AD is 1 to 3 is 2. Negative 4 to 0 is 4. 0 to 2 is 2. Okay, let's calculate it. So this is gonna be, delete the first part, this multiply minus that 1. So minus 4 minus 8. So delete the second line, this multiplication minus that 1. So 2 to 4 minus 4 to 2 times 2 is negative 8. So delete the third line, this multiplication minus that 1. So 4, 4, 16. No, sorry, minus 4 to 4 is minus 16 minus 2 minus 2 is minus 4. So it's actually minus 12 plus 12 and minus 12. This one is m times, which is 12 times minus 1, 1 minus 1, right? So, okay, so value of m is actually 12, which is a positive integer. Okay, hence to find the area of parallelogram ABCD. So the area of parallelogram ABCD is exactly equal to the AB vector cross product of A to the D vector of this magnitude. Right, so this is actually ABAD is because 12 times minus 1, 1 minus 1, this is absolute value of that one, equals 12 equal in front of absolute value of minus 1, 1 minus 1, equals 12 times of square root of 1 plus 1 plus 1 equals 12 times square root of 3. This is the area of a parallelogram ABCD. Okay, plane pi 1 contains parallelogram ABCD. Find the Cartesian equation of pi 1 that contains ABCD parallelogram. We can use directly use this vector over here. This is directional vector of the plane, so we can say negative x plus y negative z minus z equals d, and all we have to do just plug in one of the point from the equations. Just plug a point to that equation. Minus so we got minus minus 1 minus 4 minus 0 equal d. So d is negative 5. So equation of pi 1 equation pi 1 must be minus x plus y minus z equals minus 5. This is equation of pi. Okay, the second plane pi 2 has a Cartesian equation of that one. The acute angle between pi 1 and pi 2 is theta. Show that the cosine theta is 5 over 1. So so what it asks us is, this is pi 2, and this is pi 1. Acute angle between two planes is the angle between two planes normal vector, and that is true. So all you have to do is we can define cosine of theta. Let theta become the acute angle between two planes, and this will become first vector's this vector pi 1 is normal vector is minus 1, 1, minus 1. So minus 1, 1, minus 1. Dot product of vector, this vector's normal vector is 5, 1, negative 7. 5, 1, negative 7. This all over magnitude of first vector square root of 3. Magnitude of second vector. Second normal vector's magnitude of pi 2 is 5 squared is 25 plus 1 squared is 1 minus 7 squared is 49. We can just calculate this one, see what happens. So if you calculate the numerator, we got minus 5 plus 1 plus 7 over square root of 3, and square root of 50 plus 25 is 75. Okay, so we got 3 over square root of 3. So let's say 75, we can factorize it. Divided by 5 is 1, 5, 5, 3. So this is 5 square root of 3. And then this cancels out. And finally, we got cosine theta is 1 over 5. This is true. Okay. Next question. The line L passes through E and is perpendicular to pi 1. Line L intersects the plane pi 2 at F. Find the coordinate of F. Okay. So what it says is there is a pi 1, and then this pi 1 equation was what? Minus x plus y minus z equals negative 5. And point E, the point E coordinate is over here. We already got it. 0, negative 3, 2. So point E is right at the midpoint of this parallelogram, and this coordinate is I forgot. Okay, 0, negative 3, 2. So this coordinate is 0, negative 3, 2. Is that right? 0, negative 3, 2. This is point E. And then what it says is line L passes through E and is perpendicular to pi 1. So this is line L. This is line L. This is line L. So because line L is perpendicular pi 1, line L can be defined. Line L can be defined as a vector equation R, and one of its coordinates, it passes through E, this point, which is this point. So we can write it down 0, negative 3, 2 plus lambda times its directional vector is exactly same as a normal vector pi 1, which is negative 1, 1, negative 1. This is the equation of L. And then line L intersect pi 2 at point F. Find the coordinate of F. So line L can be defined as parametric equation. We can say 0 pro minus lambda. Minus lambda, y value is minus 3 plus lambda, z value is 2 minus lambda. This is line L equation. And this equation meets, which point? This equation meets equation of, this point meets equation of that one over here. So what we can do is we can just directly plug in this waypoint, this point of L into the plane equation of pi 2, which means that 5 times minus lambda plus y is negative 3 plus lambda minus 7 times z is 2 minus lambda should be 1. We only have to find a lambda value to get the coordinate of F. Okay, expanding everything, we got 5 minus 5 lambda minus 3 plus lambda minus 14 plus 7 lambda equal 1. And this is 8 lambda minus 5 lambda. We got 3 lambda on the left side. On the right side, we got 1. This is a negative, this 2 is a negative 17, goes to plus 17. We got 18 on the right side. So which means that lambda must be 6. So put lambda 6 into that equation. So finally, we got the coordinate of F is minus 6, 3, minus 4. Yeah, this is, let me rewrite this minus 4. This is coordinate of F. Okay.